Thank you so much. Thank you for being here. Yeah, like Dr. Branson mentioned, my paper is about estimating the lifespan of power wheelchair electronics using real-world data. And I collaborated with Dr. Richard Schein, Dr. Mark Schmeler, and Dr. Gede Pramana. I'm a recent graduate from the Pitt Master of Rehabilitation Technology program, and currently I'm working as an ATP at New Motion since about August. But before I begin presenting about the findings of our research, I wanted to share a little bit about my first experience buying a car, and I hope you can see some of the parallels with power wheelchairs too. So there are a lot of factors to consider when purchasing a new car, as many of you probably know. But for me, I'm not really a huge car guy, so I tried to take a more practical approach. And these are some of the factors that I considered. One is the features. I wanted to be able to drive safely, have a backup camera, and things like that. It also needed to fit with my funding sources. I was starting my first job at the time, and so affordability was definitely very important. Size, of course, needed to fit in my parking spot, be comfortable to drive, and have enough leg room for me too. And I did honestly care a little bit about the design, so I wanted to look cool in my new car. But the most important factor for me was definitely the reliability. I wanted to know that whatever car I choose, it's going to get me from point A to point B reliably, and I don't want to worry about unexpected failures or down the line, what kinds of unexpected or expensive repairs, um, I might be faced with. So when it came time to actually choose the model of a car, there were a lot of resources online that I could find reliability ratings, such as on JD Power, that you may have used before too. And at the time, the Kia Optima had a pretty good rating on JD Power. And so that ultimately was the car that I chose. And for the past 5 years, that's the car that I've been driving without any reliability issues. Hopefully by now you're kind of seeing some of the same parallels with choosing the right power wheelchair too. A lot of these factors and considerations are the same. But I might argue that reliability is even more important for a power wheelchair, as those users are using their chair all day, every day. But the problem is that as an ATP practicing in the field, one of the most common and difficult questions that I'm asked a lot is this power wheelchair going to last me? How long is it really going to, help me with independence and quality of life? But there really aren't that many resources available to me or to the users on which models have the best reliability rating. And that kind of information is very important to the users, but also to me as an ATP wanting to provide, the best kind of equipment. So that's what our study aims to kind of bridge the gap on. Our research aimed to inspire a data-driven approach to estimating specifically for power wheelchair electronics, the lifespan that can help provide important insight for funding policy, for device selection, and for maintenance plans. A similar study was done by Alberto Nieto and our team on specific to power wheelchair batteries. And what they were able to find was that there is significant variability in battery lifespan. And there are some factors that are significant predictors of that, such as the operating climate temperature or the specific manufacturer of that power wheelchair. So that's kind of the same approach that we tried to take with this study. And during our literature review, we found that electronics issues are among the most common repairs that power wheelchair users are faced with. And they also lead to the most secondary adverse consequences. So they're very high risk. Those can be issues such as being stranded alone or missing doctor's appointments. So that's where we focused our study. Our research had two main objectives. The first was to estimate roughly the lifespan of power wheelchair electronics. And two, it was to identify potential contributors to that variability. So those were our main objectives that I'll try to cover here. Similar to the battery lifespan study, our research also looked at retrospective data from the Wheelchair Repair Registry, which you may have heard of before. It's a large repository of US service data on wheelchairs, and it's really designed to inform studies such as this. We did need to filter out and sort the data to create a robust sample size, a robust data set. So we applied some inclusion and exclusion criteria to reach that. At the bottom here is an example of a service ticket from the Wheelchair Repair Registry. And since our study was specifically focused on electronics, we've also filtered on the electronics and related category. So once we applied all those inclusion and exclusion criteria, we came up with 1,268 total power wheelchairs. Within that data set, we covered group 2 and group 3 power wheelchairs. We had 3 different distribution years from 2016 to 2018 to capture that full lifespan. And we also included 4 different manufacturers that are anonymized here. But just one note on that is that -1 of the group 2 power wheelchairs that we captured in our study, all of them were under manufacturer C. So that's what you see there in the middle of the third graph, just a separate column that distinguishes manufacturer C, group 2 versus group 3 power wheelchairs. Within our data set, we found that 29.2% of those power wheelchairs encountered some kind of electronics repair in its lifespan. And we calculated a median lifespan before an electronics or related repair at 32.2 months. And that's roughly 2.5 years. So to dig a little bit further and search for those factors that might contribute to that variability, we performed a 2-step statistical survival analysis. It first involved a univariate analysis using the Kaplan-Meier method, and then second, a multivariate using the Cox proportional model. And so we'll talk through each of those as well. First, in the univariate analysis, we were looking for significant differences within each variable. So for example, group 2s versus group 3s. And it might be a little bit hard to see here, but you're seeing the 3 sets of survival curves that were produced specifically for each of those different variables, for the type of device, for the distribution year, and for the manufacturer. And for all 3, we found that there is a significant variability in lifespan for each of those different variables. A little bit about the survival curve. It's showing you on the y-axis the probability of survival, and on the x-axis is the age in months. So at time 0, we have 100% survival. And as time goes on, as age increases, we have a slow decline or fallout due to those electronics and related issues. So as I mentioned, on all 3 of these, you see a significant difference in survival. And so we know that the lifespan of power wheelchairs electronics does vary significantly based on these 3 different characteristics. So we took each of those significant variables and we fed that into our multivariate analysis, which I'll show here. And the multivariate analysis was a more holistic approach to looking at the entire set of explanatory variables and their relationship with that specific outcome. For each of those explanatory variables, we calculated a hazard ratio or the relative risk. And just a little bit about that, a greater hazard ratio in this case indicates a greater risk of failure. So I tried to highlight here some of the notable findings we had, and we identified 3 statistically significant predictors of a greater risk of failure in the power wheelchair electronics. And interestingly, that included a distribution year in 2018, distribution year in 2017, and then being a group 3 power wheelchair. We also found that manufacturer D was marginally a significant predictor. So it technically did not meet the alpha level for our study, but still a notable finding. So what do these findings actually mean? We first estimated the median lifespan of power wheelchair electronics at 32.2 months, which is about 2.5 years, as I mentioned. And that's well before the 5-year limit before Medicare will typically fund a new device. Currently, Medicare does fund repairs, but more on an ad hoc basis. And as I mentioned, electronics issues lead to very severe consequences sometimes. They're very high risk. So oftentimes it's too late to wait for that to happen in order to take to do a repair or to maintain your device. Imagine having an unexpected joystick failure and you're stranded outside and it's raining and you lead to further issues with your power wheelchair. And now Medicare is expecting, or they're surprised with a replacement of a device 2 or 3 years before they're typically expecting to. So as I mentioned, it's often too late to wait until something like that happens. And what we'd like to do in the future is to take a more proactive approach. We also found significant variability and identified a few significant predictors of a greater risk of failure in electronics. And this is important for a variety of reasons. But one, as I mentioned before, as an ATP, I want to provide equipment that I'm confident is going to work well for my clients and also for the end user who are equally a part of that device selection process. They're entitled to that information too. They should be able to find that and be able to participate in the decision making so that they can choose a device too that'll work for them and prioritize based on their needs and goals what's going to work best. And second, this analysis hopefully should point out to funding sources and to Medicare that a generic funding policy approach, it just isn't enough. Evidently, we see a significant variability in lifespan in real equipment that's used in the world. And so pretty much anyone in the field would also agree that no two users are exactly the same and no two wheelchairs are exactly the same. And so it only makes sense that complex rehab technology also requires a well thought out, inclusive, and representative policy so that we can ensure that our users are able to use their equipment safely and reliably. Our study really just scratches the surface. Even in the last talk about looking at data and proactive maintenance, I think we're really starting to make strides in encouraging a more proactive approach. And that's, again, what we hope to do with this study too. We would like to definitely perform larger studies, include a larger data set that includes more types of devices, more users, more geographical areas to further validate our findings. And it would also be nice to develop some kind of detailed list or spreadsheet or some kind of source that can share this kind of reliability data for suppliers, manufacturers, for users, and funding sources. We definitely need to dig further into these specific predictors as well. We were a little perplexed about the distribution year in 2017 and 2018 about why is that associated with a greater risk of failure? And so we definitely need more, a little bit more digging on that. Group threes, they involve more seating functions, more complex electronics. So that was a little bit more expected. But also differences in manufacturers, that's something that we definitely need to look into as well. So we hope that in further studies, we can understand exactly what those causes are, what those reasons are, and also feed that information to suppliers, to users, to funding sources, to inspire more strategic maintenance plans, to improve our funding policy approach, and even for end users, maybe give them some hints. What are some of the things that are common issues that might come up? Improving our 19-point inspection from a vendor perspective, so that we can get ahead of these kinds of failures and ensure, again, that our users are safe. Thank you so much for your time, and I would love to answer any questions in the back.